Hello everyone, this is the third video of convolutional neural network. We discussed about the convolutional layer. Now we are going with the stride point. Stride. What is the stride? Here stride means how many pixels we are moving the kernel over the image. That is called the stride. So here this is the convolution with the stride 1. If you use stride 1, then 5 by 5 image can be feature map will be generated with 3 by 3. That we have given the formula also in the previous slides. So if you apply the 2 stride 2, then 2 pixels will be moved, so that we will get a small, very small image. So like this we can fix the stride to move over the image. If you want to if you want to analyze the very large images like satellite images and very large size images, in such cases we can go with the little large kernel sizes, and stride can be also increased so that we can move over the image little fast. So in that situations we can apply this, and of course for some complex analysis also we can modify the stride and the kernel size. Now padding concept. Now padding means, see, if you take the 5 by 5 in this example only, if you use the 5 by 5 image, if your input is 5 by 5 and the feature map, if you apply the 3 by 3 kernel on top of 5 by 5 image, we are getting the 3 by 3 image feature map. And I don't want to lose that. Actually, if you observe in this case, yes, if the stride is, if the kernel is working on this pixels, then it is analyzing these pixels and then moving to these pixels. And now what about this pixel? And what about this pixel? What about this pixel? This pixel is analyzing number of times. You can observe that it is becoming green number of times. But if you observe this pixel and this, and of course these also, they are having very less opportunity to analyze. So I want to analyze those pixels also. In that situation, what we can do is padding. If we add the additional pixels around the image, then 5 by 5 image is becoming as the 7 by 7. So in this we can move over the image, padded image, this additional adding this additional pixels, it is called the padding. It is called the padding. Now if you apply the kernel over the 7 by 7 image, the output will be, according to that formula, the output will be 5 by 5 image. Now you can observe that this pixel is involving in the convolution number of times compared to previous one. If you add one more padding also, one more level of padding, then it can be involved more. Of course, it may be the overfit also. It may lead the overfit also. So we don't want to do that. So in some situations, it is better to use the padding to analyze each and every pixel and to reduce the loss of the image size, image dimension. In some situations, we should not lose the image size. In ResNet, like that, some type of networks, we should not lose the size of the image, meaning that the dimensionality of the image. So in that situation, we can use the padding concept. So adding additional bit. Now there is a computation again for the padding. If you add the padding, what is the computation? I have provided the equations. This is self-explanatory. I need not explain that separately. And now computation of the output volume also, how we can compute, that is straightforward with the formulas. What is the width, what is the height, W minus F, and then filter size. F means a filter size, or that is receptive field size, and the S plus 1, S means stride plus 1. So and then D means depth, meaning that how many number of kernels we are using, how many number of filters we are applying. So that is the depth. height, width and depth. We are getting this, that you can easily calculate with this. I have given one example also in the slides. You can go through this. I don't want to drag this session more. So, and then activation layer. As we discussed about that activation layers in the previous units, that there are a number of activation layers are there, activation functions are there. All those activation functions can be applied here also. And now pooling layer. Now what is the pooling? Pooling means sometimes we may have very large image, but the intensity of that image may be very less, meaning that only some pixels are giving some intensity of the image, but some pixels may be we can remove them. So for that purpose we are using the pooling layer. So what is the pooling layer is, we will take the size of the pooling layer also, we will provide. Here in this example 2 by 2 pooling we are applying. If you apply the 2 by 2 pooling layer, this is the image. In this image, first 4 pixels will be on the 2 by 2 pool. Out of that, there are the two types of pooling, average and max. Out of this max pooling, the maximum value will be considered out of these 4 values, meaning that from 4 values we are taking one value. So 100 will be taken, and in this we are getting the highest value 184, meaning that we are not losing the intensity of the area. We are getting the intensity of that area and we are removing the unnecessary pixels. So this is the pooling concept. But sometimes we may lose the important features also. In those situations we can use the average pooling. Instead of taking the highest value, it will take the average of all these values of the pooling area and it will be taken. This is the average of these 4. This is the average of these 4 pink color values, like that, so that it will reduce the dimensionality of the image. So please remember that padding is different and pooling is different. Padding is a small technique used in the convolutional layer. Pooling is a separate layer which will reduce the dimensionality of the image. And how to calculate again the image, meaning that the pooling layer, if you apply the pooling layer, how to calculate that? Again, there are the formulas, similar formulas only. We have seen how to calculate the number of convolutionals and the output of output, that is the feature map size. How can we determine? We already have done that, and this is also straight away the equations are given. We can go with that. And now subsampling, that is the pooling only. Pooling is also called the subsampling. Now you can observe that this is the 224 by 224 image that is giving to the pooling layer. So if you apply the pooling layer, that is the downsampling to 112 by 112, and if you observe, this is the edge, you can observe that it is having some intensity. Now you can observe that that intensity is not missing. The intensity is there, but which is having not important pixels, those are removing. So you can observe that. So the pooling layer, it will take the important features, important pixels and high intensity pixels and remove the low intensity values, low intensity pixels, so that we can get the important features only. Our feature map will be generated with important pixels, right? And subsampling, again the subsampling we can apply the convolutional, same concept of convolutional. I don't want to touch this topic at this moment. After providing the combination of different layers, finally we will reach the fully connected layer. It is regular dense layer for us. Okay, we have to flatten. See here we are having the image and we are having the number of features, and number of features like this, several convolutionals are completed, convolution, pooling and all these combinations. Finally we are here. These features have to be flattened and they will take the pixels, meaning that the flattened image here flattened feature map, and then that can be connected to various levels of dense layers. Finally we will go for the classification layer. Finally we will go for the classification layer. So this is the fully connected layer. The last layer may be the softmax. In general it will be the softmax. And loss layer. After completion of this, we will go with the loss. We have to calculate the loss. Which loss function we are using? Based on that, the loss will be calculated. Here the binary cross entropy and categorical cross entropy, all these are applied. So in general, we will have the cross entropy as the loss, because the convolutional neural networks, in most of the cases, we are using this for the classification. So we are going with the cross entropy as the loss function. And one more thing is also there, that is called the dropout layer. It will drop the units of the layers randomly to reduce the overfitting. Sometimes our model will be perfect for the trained data, and for it may not work properly for the test data. So in those situations, we can apply the dropout layer so that some features will be intentionally dropped. Randomly, intentionally, they will be dropped, so that we can reduce the chances of overfitting. This is the dropout layer. For this, we have to provide the probability, that is the ratio, how much ratio you want to reduce, the percentage you have to reduce. 0.2 means 2% will be reduced. 2% of the units will be reduced. Like this, we can use the dropout layer. And back propagation, this is same as our regular neural network back propagation, but the base, again it is based on the loss function and the gradient descent, whatever the back propagation algorithm we are using, based on that dl by dz, and we are applying the dl by dx, dl by dy. We have to calculate all these gradients, and we have to go back propagation and update all the weights, and we can train the model. I don't want to stress much on this, but only the thing is, step by step for all the pixels in the convolutions, if you use the convolution, you can see that these are the convolutions already, you know, x11 into w11, x12 into w12, like this we are having the convolved feature. This is in the forward pass, and in the backward pass we are having the H1, H11, H12, H21, H22, and finally we are going back. Actually we have to go back for this. Actually this is also the forward pass. We are going with the forward pass. After that, back propagation is based on this. So dou H11 by dou H12, dou H11, dou H12, and so on. We have to perform this. The gradient for the loss function, and then gradients for the previous layer and kernel, and go backward, and one by one we have to update these weights. We have to update these weights. This is the back propagation algorithm. Mathematically it is having more depth. I am not going with that. I am just introducing what is there. And CNN implementation, I have already provided one video for the CNN program. In that we covered all the topics, importing the required libraries, loading the data validation, creation of the convolutions, and train the model, evaluate the model, predicting the model label. All these already we have done in that video. You can go through that video so that you will get a complete picture on the CNN implementation. So here in these slides also I have provided some CIFAR data set, and you can build that. Once if you build the model, you have to compile this. You have to compile the model. Say this, we can add the layers.conv2d of 32 filters with a 3x3 kernel. Activation is ReLU, and input shape is 32 by 32 by 3. And I am adding the max pooling layer with 2 by 2, and again I am applying the convolutional 2D with 64 kernels, meaning the 64 feature maps will be generated, and 3 by 3 kernel again, activation is ReLU, and so on. In this way we can build the convolutional neural network, and then we can add the dense layer. After the convolutional neural network, we can go convolutional layers, we can go for the flattening, and then dense, we can use number of dense layers, and then finally we have the 10 classes, so that final layer is having dense of 10, and the activation most probably it is the softmax. So, and after completion of that, we have to compile the model. For compilation of the model, already it was discussed in the previous unit. How to compile the model, model.compile of optimizer, loss and metrics you have to mention. And to train the model, model.fit, this is the training the model. So this is in this way you can get the output of by training. After that you will get the evaluation also. So that, okay, so this is what I want to discuss about the convolutional neural network. Thank you.